So how to achieve this maximum power transfer? There are quite a few techniques to do that. One of the techniques is to use what is called as a quarter wave transformer. We know that when you have a certain ZL at the load at a certain distance L, this ZL transforms to the Z in. But if I want to connect it to a certain RS, all I want to make sure is this Rn is equal to RS. As long as this is there, then I achieve my matching. I can achieve my matching. So if I have RL here, then my impedance at a length of lambda by 4 is going to be Z0 square over lambda L. Why that so? Because when L equal to lambda by 4, your beta L is going to be 2 pi over lambda times lambda by 4, which is pi upon 2. And this term becomes pi upon 2, and tangent pi upon 2 is infinity, so you're doing it in the limiting case, it would turn out to be Z0 square over ZL. You got this to be infinity as well, so you're going to do divide throughout the numerator and denominator by tangent beta L. So you will see that this term remains and this term remains. It's going to be Z0 square over ZL. So this, whatever load impedance you have 1 over ZL at a quarter wavelength away. So that becomes a quarter wave transformer. You can use this for matching. For example, where you want to have the Z0 to be whatever ZL that you have here times whatever Z in that you want to achieve, the square root of that 2 is going to give you, when the Z0 is going to be square root of Z in ZL, it's going to be matched. The Z in will be equal to ZL if my Z0 is this term. If my Z0 is square root of ZL times Z in, that's a quarter wave transformer. Similarly, another important fact is if this is quarter wavelength long, you see it becomes 1 over ZL. But if you were to go further down, if it is half wavelength long, then whatever that you had here, the ZL is exactly what you will have here when it is 1 wavelength long. So it is as if that this section is not even existent. Yeah, this section of transmission line is not even existent. So if you go ahead and substitute beta L with L equal to lambda by 2, if you go ahead and substitute beta L there, you will notice that your Z in of L is going to be equal to ZL already when L equal to lambda by 2. That's half wavelength. So quarter wavelength can be used for impedance matching.